Hello everyone, welcome back to my YouTube channel. So in day 10 of AWS series, today we are going to understand components of virtual private cloud. In previous video we have discussed what is virtual private cloud, in short form we call it as VPC. In this video we are going to see what all the components we have to create or configure as part of virtual private cloud. So the very first component is CIDR block. So CIDR stands for classless inter-domain routing. In simple terms, it defines the IP range for your virtual private cloud. So based on that, this particular IP range, we can define okay how big our network is going to be. For example, suppose if you are working in an organization and every user is connected to the office network, then each user will have their own IP address. Like for example, I'm getting 10.0.0.1, somebody is getting 10.0.0.2. So basically this is for the identification purpose of that particular user, and that particular user can access the resources of your organization. So same concept is in AWS. So suppose we are going to create thousand of EC2 instance in AWS, then each EC2 instance should have a one IP address. So accordingly we have to specify, or we need to select the range based on the network, based on the basically I would say resources which we are going to provision as part of our virtual private cloud. So CIDR block notation is something like 10.0.0./16. So what does it mean? Basically the network start at 10.0.0.0, and /16 means the first bits are fixed for the network and the remaining bits are available for host addresses, means EC2 instances. So what does it mean basically? So 10.0, the first two digit or two byte bits basically reserved to identify the network, and the last two digit 0.0, these will be changed. So for example, this could be 1.0, 2.0, 3.0, 4.0, or maybe 0.1, 0.2, 0.3, 0.4. So like that, basically these bits, last two bits will be changed, because these bits will assign or will be available for your EC2 instances or other resources which we are going to provision, and these initial two bits will be fixed here. So if you are using /16 notation, in that case you are getting 65,536 total IP addresses. So think of it as you are you are reserving a plot of land, means you are reserving a IP address range which you can later divide into rooms. It means subnets. So we have reserved this particular range 10.0.0/16. Now within this range we can divide this range in multiple subnets, means if we are using /16 we are getting 65,536. Now for example, we need to create multiple subnets as part of this virtual this IP range. In that case we will start changing the last notation, like instead of 16 we'll put 17, 18, 19, 20, and these ranges should be between /16 to /28. Between that only we can assign or we can create a subnets. So if I give you a quick overview here, if I go to here CIDR, I have already discussed in previous slides. Let me go in this video as well. Sorry, in previous video. So how you will identify the, like how many IP addresses you are going to receive or get. So for example, I have defined it 10.0.0, and here I will also put 0. And here for example I have defined /16. So it means total 65,536 IP addresses we will get. Now these two bits will be fixed as I told you. The last two digits or bits will be changed. So for example, if here I put 1. Let me close 1.0/16, in that case we are getting again 65,536 IP. Now if I'll change here /16 to /24, in that case we will get 256 IP addresses. Suppose we need to create two subnet as part of this IP range, private subnet and public subnet. So for private subnet we have choosing 1.0/24, and for Public subnet, for example, we have chosen this particular range. So in both the range we will get 256 IP addresses. I hope it's clear. If not, please ping me over comment. Definitely I'll answer your question as soon as possible. So this is the use of CIDR block. This is the first thing you have to specify when you create a virtual private cloud. So this is the very first component. Now the subnet. A subnet basically is short for subnetwork. So basically you have defined a CIDR notation or IP range for your virtual private cloud. Now you have to divide, like you have to create a multiple small networks from that particular IP range. That is called a subnet, a small portion of your CIDR notation. So when you create a VPC, you are giving a big block of IP address. For example, this, which we already discussed. So you then divide this block into a smaller section called subnet. So from this particular range, we are creating multiple smaller networks. You can think subnet like room within your house. So your house, maybe virtual private cloud is your house. Now you are creating a multiple rooms inside your house. So each house will have their own like room 1, room 2, room 3, room 4. So same concept is here with virtual private and the virtual private with subnet and CIDR block. So there are two types of subnet you can create: public subnet and private subnet. Public subnet means can access the internet, like this is generally used for your web applications, and private subnet generally we use for database purpose because we don't need a direct access on this particular network. So here no direct internet access unless we specify any kind of NAT gateway for outbound traffic. So if I'll give you a quick overview from this image. So this is our virtual private cloud. Under this we are creating a public subnet and private subnet. You can see the range here, like 1.0 we have specified for public subnet and 2.0 we have specified for private subnet, and in both the public and private we can see the first 2 bits will be same and the last 2 bits will be changed. Now route tables, or I would say route tables. So a route table in AWS is like a set of traffic rules for a subnet. It tells the network where to send traffic based on the destination IP address. For example, in public subnet we want to allow traffic from internet, but in private we don't want to allow traffic from the internet. So we create a route table to basically distribute, or basically to flow the traffic from your inside a virtual private cloud. And each subnet in VPC must be associated with one route table. So for example, we have created 2 subnets, public and private. So each subnet will have their own route tables. So in simple terms, you can think about route table as a GPS navigation system in your virtual private cloud, which decide okay which road you have to take depending on where you want to go. How does it work? So a route table contains a destination where the traffic is going. So for example, if we specify this in this format 0.0.0/0, it means the traffic is going to a internet. Another option, or another option, it contains targets where to send traffic: internet gateway, NAT gateway, or locally. So we will see route tables when we do a demonstration in next video, so it will be more clear. Just for the in simple terms, just understand the route table is kind of a navigation system for your virtual private cloud, which decide okay which traffic or which traffic will go under which particular network. Then we have an internet gateway. So an internet gateway in AWS is a component that allows communication between instances in your virtual private cloud and the internet. It serves as a bridge between the VPC and public internet. So you have hosted your web application on your public subnet. Until you will not specify an internet gateway, you cannot access your application, because the subnet, you have defined the route tables, but still the route tables will tell the traffic okay you have to go to this particular subnet of this particular resources. But if somebody is accessing your application from the internet, then how he will know where the request needs to go? So internet gateway act as a main node for your EC2 instances or for your applications. So from this internet gateway, your application flow or the traffic will flow start, like it will go to internet gateway, then from there it will go to some kind of routers, from routers it will go to route tables, from route tables it will go to what is called network access control list, then it will go to a security groups, from security groups then it will go to a EC2 instance or the application which you have hosted. So this is the traffic flow to access your application using the from the internet. So how it works basically, so by default instance in VPC are isolated from the internet. So whenever you create a virtual private cloud, you have to manually create an internet gateway and you have to associate internet gateway with your virtual private cloud. An internet gateway must be attached to the VPC to allow internet communication. A route table must direct traffic to the this particular range to the internet gateway for outbound and internet access. So we will see in a demonstration that it will be more clear. Just for understand, just think about internet gateway is a main door to access your application from internet. So what all the requirements we need for internet access via internet gateway? So first thing, you should have a public subnet which should associated us with a route table that send traffic to this particular range. Then you have public IP address, then you have security groups and internet gateway attachment. The internet gateway must be attached to the virtual private cloud which you are using. Then we have a NAT gateway. So NAT stands for network address translation. So it basically allow resources in a private subnet like EC2 instances or database to access the internet, but prevent the internet from being initiating a connection back to them. So basically it send a traffic one way. Suppose you have created a EC2 instance on Linux base. Now you want to, as we know in Linux, we need to download the packages, we need to install the softwares. For that we need an internet connection. So for that purpose we can use NAT gateway. So what does it mean? The EC2 instance can request the data or packets from the internet, but if somebody is trying to access your application through the internet, they can't enter in your network, or if they can't access your private subnet where your application resides. So example, your private subnet is a back office with no direct internet access for security reasons. But those machines still needs to download software, updates, pull package from the internet. So instead of giving them a public IP, you let them go through the NAT gateway, which send the request to internet, receive the response, pass it back inside the private subnet, but no one from the internet can reach those private resources directly. So this is the purpose of NAT gateway. Again, in demonstration it will be more clear. Just for now, just understand, from NAT, using the NAT gateway we can access the internet from our private subnet, but somebody who is sitting on the internet, they cannot access your resources directly which are in private subnet. Then another component here we have VPC peering. This is called virtual private cloud peering. It's like building a private bridge between two VPC cloud, so you can talk to each other directly. For example, you have VPC A and VPC B. Some resources are on VPC A and some resources are on VPC B. Now by default, the resources, for example, we have one EC2 instance in VPC A and another EC2 instance in VPC B. Then the EC2 instance in both the VPC cannot communicate with each other because they are in different network itself. So to communicate those resources which are on different virtual private cloud, we create something called VPC peering. and it basically works with the same AWS account or across different AWS accounts. It is not like you are using AWS account and somebody is using another AWS account. So you can stabilize a peering between two AWS account. It's not mandatory you should be on a same AWS account. For this communication, you don't need any kind of internet, VPN or NAT. Communication happen entirely within the AWS network. It works basically, you create a VPC peering connection between VPC A and VPC B. Both VPC must update their route tables to recognize each other's CIDR block. Once peering is active, the routing is configured. EC2 instances or services in one VPC can communicate with other using the private IP address. So in VPC peering, you don't need any kind of public connectivity to communicate between different network. Here you can communicate with the private network as well. And one important point here is peering does not allow transitive peering. What does it mean basically? Suppose you have three VPC A, B and C, and you have stabilized a peering between A to B and B to C. It means the resources which are on VPC A cannot communicate to VPC, but the resources in VPC B can communicate to VPC. So what you have to do, again you have to create another peering between A to C so the resources can communicate with each other. So that's all for today. I hope it's clear the components which use as part of when we create a virtual private cloud. So that's all. See you in next video. Thank you so much.